Okay everyone, welcome to video 7. This is the final video in this sort of list, and it's actually taking a very old exam question on this topic and just going through it. So do pause it now and have a go. Okay, fantastic. Right, on we go. Let me just obliterate. Okay, so find the probability that x is greater than e of x. So let's talk about how we might write that. We're asked to find the probability that capital X is greater than, and we're actually told what the expected value is in the question, greater than 0.95. Okay, let's think. So this random thing, this is an object which can either equal -1 or 0 or 1 or 2 or 3 or whatever. And we're asked to find the probability that's bigger than 0.95. That's the same as the probability that x equals 1 plus the probability that x equals 2 plus the probability that x equals 3. Those are the only ways it can be bigger than 0.5. And I'm allowed to add the probabilities together because these things are mutually exclusive. And these things I can read off from the table. The probability that x equals 1 is 0.1. Probability x equals 2 is 0.3. So the answer to part I is 0.1 plus 0.3 plus 0.2, which is 0.6. There it is. Okay. Now, much more meaty. Find the values of a and b. Right. So we've got two unknowns. It's a very classic kind of AS level maths thing. Two unknowns, two bits of information we need to use. Let's go back and look at our formulae. Which formulae might we be able to use here? So I go back a page, to our final all-important formulae. We're going to be able to use this one and this one. We know the probability is sum to 1, so we can write that down, and we also are given information about the expected value. Okay, so let's have a go. Probability is sum to 1, so let's write that down. That's a plus b plus all those other three, which is 0.6, is equal to 1. So we get an equation. A plus b equals 0.4. We're hoping to get another equation linking a and b, and then we'll be able to solve some simultaneous equations. Okay, so let's look at the expected value. The expected value, I'll quote the formula again to remind us. Sigma xi pi. That means you take each x value, multiply it by its corresponding probability, add everything together. We know what that is. 0.95 is equal to, x can be -1. -1 times a plus 0 times b, that's handy, plus 1 times its corresponding probability 0.1 plus 2 times 0.3 plus 3 times 0.2. So let's do a bit of working out on that. 0.95 equals minus a. 0b actually disappears. This is going to be a very simple equation. 0.1, 0.6 and 0.6 is plus 1.3. So I guess we get a equals 0.35. Now, we're very fortunate that this second equation doesn't actually involve a b, so we just get the value of a immediately. It would be totally reasonable to have a question where this second equation from the expectation involved both a and b and you had to solve simultaneously. Technically, I suppose we are still solving simultaneously. A is 0.35 and a plus b is 0.4, so b equals 0.05. I would still be tempted, just force of habit, to write this as ab equals 0.35 and 0.05 as my final answer. Final answer to that part of the question. Okay. We have one more part to do, I think. Ah, yes, we've got to calculate the variance. Okay. We've got plenty of space, right. Okay. Yeah, I'm going to delete some of the stuff we've done earlier. Give us a chance to see everything once. Okay, so downstairs. Right. Okay, so let's have a go at finding the variance. So we're going to use the formula which was on the previous page, the last one. Here it is. Sigma xi squared pi minus e of x squared. Okay, let's have a go. So var of x equals, quote the formula, good practice, xi squared pi minus e of x all squared. Okay, so what is that? That is minus 1 squared times a. Now a is 0.35. Plus 0 squared times b, which is 0.05. Plus 1 squared times its corresponding probability. Notice I'm squaring the values, not the probabilities. 2 squared times 0.3 plus 3 squared times 0.2 minus, we know the expected value, it's given in the question, 0.95 squared. Okay. So let's calculate that. That is, minus 1 squared is 1, so I get 0.35. 0 squared is 0, it goes away. Plus 0.1, that's 1 times 0.1. Plus, I think, 1.2, 4 times 0.3. Plus 1.8 for 9 times 0.2. Minus 0.95 squared is 0.9025, as it turns out. Okay, so we've got 3.45 minus 0.9025, which I think is probably 2.525 for the variance. Okay, so the variance is 0.25. You can ask for the standard deviation of a random variable. Square root of that would be, I guess, just over 1.5, just a shade under 1.6. So, and again, if you look at the values, 1.5 either side of the expected value take you between -0.5 and sort of 2.5. So that wouldn't be including the -1 and the 3. So yeah, again, most of the data, or a reasonable proportion of the data, lie within one standard deviation of the expected value. So the expected value, there it is. Sorry, the variance, there it is 2.525.